So now we have discussed alkanes. Remember, the suffix here for alkane is ANE, and the general formula is CnH2n plus 2. And I told you that one carbon is met, two carbons is eth. So these are the things we discussed in alkanes. So since the suffix is ANE, then all this will be ANE. Now we are doing another one now, which is alkenes. So for alkenes now, the suffix is ENE, and the general formula is CnH2n, so short of two hydrogens from alkanes. You know alkanes is plus 2, yeah. So but alkene is CnH2n. So now let's start the naming. So this one too, let's say name and formula. So let's start with one, that is one carbon, that is met. So put the suffix, that's ENE. Then this is methane. So what do you think the general formula will be? So this should be CnH2n. So this will be C1H2 brackets 1. So this is C1H2. So this should be CH2. Now let's draw the structural formula for this pattern for this. So we have one carbon, as in CH2, one carbon, two hydrogen. Okay, look at this, two hydrogen. Now is this correct? This is correct based on this formula, but carbon must have 4 bonds. Remember, the valency of carbon is 4. I've explained this on alkane. The valency will represent their bonds. So nitrogen is in group 5, so the valency is 3, then it should have 3 bonds. Chlorine is in group 7, its valency is 1, so chlorine should have 1 bond, as in like that. So if you now look at this alkene now, which is methane that we wrote, carbon here have 2 bonds, hydrogen have 1 bond, correct, hydrogen have 1 bond, correct, but carbon have 2 bonds. So and there is no way I'll just add another 2 here without putting hydrogen here, so it's wrong. So that means it is not possible to have a single bond here. I have to have double bond, and if I have double bond, carbon is now 4 bonds, correct, then hydrogen is 2 bonds, which is wrong. So that means there is no how I want to write methane. It's not possible. So methane does not exist. So there is no how I can write methane, because anyhow you write it, it won't tally, because methane should be CH2 and this is CH2. It can only take one bond. So no how you cannot achieve correct structural pattern. So that means methane does not exist. So let's move to the second one, which is eth. 2 is 2 carbons and is eth. Now ethene. So using the same formula, CnH2n. So that will be C2, remember n is 2, C2H2 bracket 2. So this is C2H4. So ethene is C2H4. So let's draw the structural formula pattern. So this one will be C2H4. So the hydrogen should be 4. It can be like this if you like, and you can make it straight, as in you can still make the hydrogen straight if you like. What we want there is just 4 hydrogen, as in like this. Now let me explain the pattern. So now, how many bonds do you have in hydrogen here? 1, correct. How many bonds do you have here? 1, correct. But look at the carbon. How many bonds? 1, 2, 3. That means it's not correct. Carbon must have 4 bonds. and you can't attach it to empty space because there must be hydrogen, and the hydrogen is complete, so there must be double bonds. Now if I put double bonds here, is allowed. So now this is 2, 3, 4. Carbon now have 4 bonds, so that is the correct way of writing it. Here also carbon have 4 bonds, so this is 18. So now the number of bonds will even tell you how to write correct structural pattern. So let's see the next one, prop. That is for 3 carbons. So prop, propene, that is the surface. So again, CnH2n, that will be C3H2 bracket 3, that will be C3H6. That means propene is C3H6. So let's try to write it. So now to write the propane, I have 3 carbons and I have 6 oxygen. So now 1, 2, 3, 4, 5, 6. So I have 6 oxygen. But how many bonds do you have for this carbon now? The carbon here have 3 bonds, is wrong. The carbon here have 4 bonds, the middle one is correct. The carbon here have 4 bonds and 3 bonds is wrong. So now that means if you have this, the bond is not complete. There must be another bond here. And please take note of where you place the bond for now. We are not naming that, we are going to name the bond. For now, I'm just doing it like normal pattern. So place your bond after the first carbon, either here or here for first carbon. But now let's see something here. If I place the double bond here, do you know that this carbon is now 1, this is 2 making 3, then this is 4. This one is correct. Now look at the middle carbon now, 1, 2, 3 plus 2, 5. So it's wrong. Carbon must have 4 bonds because the valency is 4. So that means to write a structural pattern like this is wrong. So those valency will give you a hint of how to write correct pattern. So this is wrong now. I can't place it there. That means if I want to place it there, there won't be one hydrogen here. So look at it now. If I place it here, you will now notice that carbon is 4 bonds here, is also 4 bonds here. So that means I don't need to have one hydrogen here, is wrong. So I can later place the hydrogen here. So this is propene. So look at it very well now. You will notice now that all the carbons, see this carbon here, have 4 bonds. 4 bonds. So count the hydrogens, 1, 2, 3, 4, 5, 6. You see, and each hydrogen have 1 bonds each. 1, 1, 1, 1, like that. So this is how to write a correct structural pattern. So this is C3H6. Now if you like, you can place this double bond after the first one, the first carbon. I'm taking that place as my first carbon. So I'm taking that one as my first carbon. If I like, I can place the double bonds here after this first carbon. So it's still the same way. So that is still propene. So if you place it anywhere here, it's the same. If I do butene now, you will see different. So but for now, for the naming sake, please place everything after the first carbon, so it can form ethene, propene, butene, hexene, pentene. So be placing everything after the first carbon. Later we'll name the other one after maybe 2 carbons or 3. So now if we want to name it normal, this is propene, so this will be propan 1 in, like propa 1 in. So later I will still explain something, but 1 is invisible, so it's better you just say prop in. So prop 1 in. So that's how you should have it. That is, This double bond is after first carbon. That is why we have prop 1 in. Even though you place it here, it's still after the first carbon this way. 1, as in that means you are naming backward. So that is 1, 2. So if you say 1, 2, 3 here, it is after the 2 carbons. So you choose the closest one. I'll still give you rules in naming, but for now we are talking about the name separately. So alkanes, alkynes, alkyl, alkanol. I'll just talk about everything one by one. Later I will now do the general naming with the rules you are going to have, but for now know this one like this. So that means this is propene. We don't need to say prop 1 in, so just say propene. 1 is invisible, so we'll know how to name later. So that is why we will have double bond, because of this structure and this formula. So now anytime you now have alkenes, then it will have double bonds. If you have alkane, you have single bond, as in like that. So now let's do for boots. Boots is 4. So 4 boots. So let me explain something again. The diagram we drew now. So this hydrogen, you may see it sometimes that is not straight. You may still see it like this, is allowed, as in, so anyhow you write it, should just with 2 hydrogen. Take note. So now the next one is 4 boots. So put the surface butane. So that will be C4. Carbon is 4 there. H2 bracket 4. So that is C4 H8. So how can we draw this now? I have 4 carbons. So 1, 2, 3, 4. Then H8. So 1, 2, 3, 4, 5, 6, 7, 8. So if it is like this now, this carbon is not complete, the bond is not complete. I have to put 1 bond. So if I put it here, then this one will be 5. Then I have to remove 1 hydrogen. Either up or down, you remove 1 hydrogen. Then you need to place that hydrogen back, so it will complete 8. Because there is still extra space here. But you can't place any hydrogen here again. If you place it, you have 2 bonds, 3, 4, 5. It's wrong. Carbon must have 4 bonds. So like that. So the valency will tell you, will even give you hint on how to write correct formula pattern. So now in this case, this is butene. Now if I place this double bond here, do you see it's not after first carbon again? It will be after the second carbon. So we have to name that is but 2 in, that is after the second carbon. So if you place it, but because after second carbon can only happen once, if you like, place the double bonds. If you like, place the double bonds after first carbon. This is still butene. If you place it after second, if you go this way, 1, 2, 3, 4 is after the second. If you still go this way, 1, 2 is still after the second. So this is still butene. So now, but later we'll learn how to name completely, but for now, please place it after first carbon, so we can always have butene, ethene, propene, enzene, as in like that. So anytime we are now moving the double bond around, I will tell you what to do next. So this is butene. If you see now, this is 4 carbons, then 4 bonds, 4 bonds, 4 bonds. So all the bonds are complete now, and hydrogen have 1. So take notes, you can't place any double bonds here. If you place it, this one is now 5. So anything that make you place double bonds here, you have to remove 1 hydrogen. If you remove, then the bond will be 4. Please take note of that. That is why we have double bond in 18. So like that, because of this formula. So this is butene. So now do the rest for The next one should be pentene. So let me do one more to say number 5, pentene. So that will be C5H10, that is 2 times 5, 10. Remember 2N. So now draw the structural pattern 1, 2, 3, 4, 5. Now place the hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is normal. If I look at this is butane, as in this is sorry, pentane, because of single bonds. So it's pentane, but pentane we have additional hydrogen here. So to know this one is short of 2 hydrogen, it should be C5H12. But C5H10 now is this, but this is not correct because hydrogen must have 4 bonds. So just place 1 bond. So if carbon should have 4 bonds, then remove 1 hydrogen. If you like, remove the up one. If you like, remove the down one. Anyone is allowed. So like that. So this is pentene. So 5 carbons is pent. So if you move this carbon double bond, if you move this double bond, if you move it here, it's not pentene again. So you will number the closest number to the double bond. So this is this is after 2 carbon, pent2 in. But we are not doing this naming for now. Take note. So place anyone you are doing for now, place it after first, either here after first carbon or here, that is pentene. Take note. So what I'm doing now is just for you to be familiar with how to write the single. So we'll now start the proper naming and including the rules that guide it. But for now, study it one by one. So 5 carbons is pent, but because we have double bond, is now in. That is pentene. And know the structural general formula, CnH2n plus 2. Now we'll move to another one, which is alkyl and alkyne. So let's move on in the next video.